Hi guys, welcome back to my channel, and we are gonna start our next video, the next part of vector algebra. Before this, we had already shoot one more video about our first part in which we discuss about the introduction of vector algebra, uh, quantities and representation of vector. From today, we will move ahead to the next topic called types of vector. So let's start. Types of vector. But before going to types of vector, let's recap our previous video with a quick question. So there you go. Question is, we have to represent this graphically. So we have to represent graphically. What do we mean by that? In previous video, we studied about the representation of vector. So it means we will be given question in words, and we had to represent that vector in graph, just as question says. So our question is, here I have question. First is a displacement of 60 kilometers 40 degrees east of north. A displacement of 60 kilometers 40 degree in east of north. Let's draw. We will draw a graph here. There you go. And as you know, this is north, this is east, this is south, and this is west. Now we have to represent 60 kilometers, and 60 kilometers is a very huge number to represent. So we have to scale down. So we will write a scale. 10 kilometers equals 1 centimeter. If you're writing on your notebook, you can use this scale. So I'm gonna use this here too. So here will somewhere. Also, we have to draw 40 degree east of north. East of north means northeast. In this quadrant, the line, the vector will be drawn here. So from 40 degrees onwards, there you go. You draw the vector, and let's name it OM. That's it. This is how we represent vector on graph. A point from where it begins and an arrowhead, which is called terminal point, where it ends. And the length of the arrow is the magnitude of arrow, and the sense of direction represents as well as direction, which is of course east of north. The second question is, our displacement. Remember here the question says displacement, and displacement is already a vector quantity, so we don't need to think too much that if what happens if there is given distance. So if the distance is given there and there's direction too, then you can represent it too. But when there's direction, it's more appropriate to use the word displacement, because displacement is what the shortest distance between 2 points, and distance is actual distance covered by body to reach second point. Second question is a displacement of 50 kilometers southeast. A displacement of 50 kilometers south east. Now here we have no angle, means we can draw in any angle. So 50 kilometers somewhere here, I will draw a perfect southeast. But no, You can draw it at any angle because here it's given southeast, and southeast is a confirmed direction of this, just in between south and east at angle 45. Thus, this will be somewhere around, yeah, 45, and magnitude will be 50 kilometers. Let's name it n. This is how our question ends, and this is the solution. We were given to represent vectors graphically. 60 kilometer and 50 kilometer, they are not practically applicable to represent on a small plane surface like this, so we have to scale down very little bit. We have taken a scale 10 kilometers equals 1 centimeter, which gives us, it means we have to represent 6 centimeter of a vector on the plane. So we drew the graph, draw the line, followed the question 40 degree east of north in northeast with the 40 degree respect to the x-axis we drew, and the second question was same as well as 50 kilometers southeast, but there was no angle, but there was a confirmed direction southeast. You know, there are 8 direction in common: north, northeast, east, southeast, south, southwest, west, and northwest. Southeast is one of those common directions, so thus it will lie between east and south. So I just take the upper position angle of 45 degrees. You know, 45 is just made of 90, and southeast is also made of south and east. So it's very considerable to think that southeast will definitely lie almost 45 degree down to east. So this is how our question ends, and we will now move ahead to the types of vector, in which we will learn about various types of vector. There are specifically dual vectors that we have to learn. They can be more than dual vectors or can less be than dual vectors, but it doesn't matter because I said specifically in general. In general, there are dual vectors that we need to learn in most important scenarios. These dual vectors are used commonly. So let's move ahead to that topic, which is also the headline of the video, types of vector. So let's go ahead. So there we go. Types of vector. Let's write type of vector. Underlining this. Okay, so let's begin. The first vector that we're gonna learn is zero vector. Zero, or you can say null. Null means 0 too. So what is zero vector? It's nothing very too much hectic or very complex. Zero vector means a vector whose magnitude is 0. Thus, end it. Yeah. A vector whose magnitude is 0. Now, representation. If we were asked to represent zero vector on graph, how we gonna represent it? That's very complex work, because if there's nothing, then how can we represent nothing? So simply we have to represent it by just writing 0. It is represented by 0, because 0 already means nothing. To represent nothing, we have 0. That's it. 0 or null vector, whatever you want to say, a vector whose magnitude is 0. Thus it's 0 vector. And in easy words, this vector means it doesn't exist yet. It is yet to be existed. Its magnitude is 0. If something is 0, if something is not there, then how can we represent it? Thus we represent it by writing 0 simply. So it's called as zero vector. The second vector is unit vector. Now things are getting interesting with this vector because unit vector will be furthermore used in our chapter ahead because it will be used as unit. As you know, in physics, quantities have unit. For force there is Newton, for distance there is meter, for time there is second. So for vector, the unit vector will come out as the unit of vector. Moving ahead, we will talk about that when we will reach next parts. But right now, just we have to recall that unit vector is one of the types of vector. Unit vector. What could be the definition of unit vector? To define unit vector, I can say a vector whose modulus is unity. Oh, sorry. A vector whose modulus is unity. Now, what does modulus mean? What does unity mean? What these two words mean? These two words are one of the not very common English words that we use in our common life. Modulus, did I write? Okay, there's no O. Modulus. So modulus is simply magnitude and unity is 1. Okay, so a unit vector is a vector whose magnitude is 1. Simple. Just like zero vector whose magnitude is 0, unit vector is a vector whose magnitude is 1. That's it. It's end here. Do I need to explain more? Now there are few additional things we need to say. The unit vector in the direction of a vector is denoted by a cap. Let me write here. The unit vector in the direction of a is denoted as a cap. So, as I said, that unit vector will furthermore in depth of chapter will become the unit of vector. So, to say something in simple, to say something very easy way, we just say unit vector in direction of any. For suppose there's a direction A and there's a vector in the same sense of direction. So in saying like PQ vector, A vector, B vector, we just say A cap. A cap is the direction to represent the unit vector in the direction of A. That's it, and it is read as A cap. You know, there's a small arrow sign on the letter, which is readable as A cap, which means C. Thus, A cap modulus equals 1. This is called modulus. You know, we were given questions like -3 modulus is what? So it's 3. That's it. That's what you call modulus. Modulus means magnitude. It's just simply the number in it. From this, a thing is derived. A cap equals A by A. This is very important because furthermore in chapter there will be a formula related to this equation or this function, whatever you want to say. Here it is vector by magnitude equals direction. A cap equals A by A modulus. As I say, that modulus A means simply magnitude, and A vector, let me more clarify it. This is A vector and this is A cap. A cap simply denotes what? Direction. So it means direction equals vector by magnitude. This is our formula, this is our equation, and this will be very important in later parts of the chapter. So please recall this one. Please remember this one. What we want to do this one? Please, vector divided by magnitude equals direction. That's unit vector, a vector whose modulus is unity. The unit vector in the direction of A is denoted as A cap. So, A cap. Modulus A cap equals 1. From this we have a formula, very important formula. A cap equals A vector by A magnitude. Modulus of A. Which in words, if you want to say, direction equals vector by magnitude. So this is very important. Till now we had learned two vectors, zero vector and unit vector. Both were very simple. Zero vector whose magnitude is 0, unit vector whose magnitude is 1. Now things are getting interesting with this one. Like and unlike vector. Like and unlike vector. We had already in our previous classes learned about like fractions and unlike fractions. With some same ideology, with some same concept, we learn vectors in also like and unlike. So what will be the definition? Vectors are said to be like when they have the same sense of direction and unlike when they have opposite or different direction. Vectors are said to be like when they have same or parallel support. When they have parallel same, no, there's no parallel, same sense of directions, and unlike when opposite or different sense of direction. So in our previous video we learned about three characteristics of vector: length, support and sense. Length means magnitude, sense is the unlimited length of a vector, which every vector is a fragment, and sense simply means direction. So let me draw an example here. Suppose this is AB vector. Okay. This is MN vector. This is XY vector. This is PQ vector. This is CD vector. And this is GH vector. Now I had drawn here 6 vectors in front of you. Now AB vector and MN vector are here like vectors because they both have same sense of direction. You can see they are both in the same sense of direction. simply as same as them. XY and PQ vector are also like vector. Why? Because they have same sense of direction. Their direction is same. And but CD and GH vector are not like, because they both have different sense of direction. CD is going there, GH is going there. Thus it is unlike vector. Not only with them, you can use this from more than two vectors to find whether they are like or unlike. So this is one kind of vector, like and unlike vectors. When I say type of vectors, most of the vectors that you're gonna learn is respect to a vector. Mean there will be two vectors through which we will classify them, and they will be considered as types of vector. So it's very irony, it's very whatever you wanna say, but it is as that is it. That like and unlike vectors. There are two vectors in same sense of direction, they are called like. If they are not, simply they are unlike. So you can see everything in this slide. Let's move to the next. So moving ahead, after like and unlike vector, there is collinear vector. Collinear or parallel or parallel vectors. Now what are collinear or parallel vectors? Let me speak first, then we will write. Collinear or parallel vector are those vectors which are having same or parallel supports. As usual, I already speak about characteristics of vector, in which the second characteristic is the support of the vector. What is support? Let's recap. Support. Every vector that is represented on a graph is a fragment of a vector of unlimited length. That's what you call support. So in collinear or parallel vector, what happens that two vectors are said to be collinear when they have same or parallel supports. Vectors having same or parallel supports as it is simple. Now let's draw something. AB, MN, PQ. These are collinear vectors. Why? Because they have same or parallel support. You can see if I draw one of PQ support like this. Here you can see PQ. Here you can see MN. Here you can see AB2. See? Can you see? They are all on same supports. Thus it is collinear vector. But if I draw a vector like this, XY vector, is this collinear to all these three? No, because its support is something like this, and it's neither same, neither parallel. Thus it's not collinear. So it's very simple to say like that. Collinear or parallel vector, vectors having same or parallel supports. Let's erase this part. Yeah. So these three are called collinear. Yeah, you can say parallel vector. This is not collinear in respect to remaining three. Okay, so it's It's very simple as that. Vectors having same or parallel supports are called collinear vectors, or you can say them parallel vectors, because either same or parallel in sense of vector they are always equal. The fifth vector, the fifth type of vector is co-initial vector. Simple as you can listen. Co-initial vectors. Vectors having same initial point are called co-initial vectors. Very easy. Vectors having same initial point are called co-initial vectors. As simple as that. Suppose this is a point here. Let's say this one x. Now xy, xa, xb. They are all co-initial. Why? Because ax vector, xy vector, xb vector has same initial point, which is x. Thus they are co-initial vectors. As simple as you can see. Next is coplanar vector. This one is very interesting. Many of us make mistakes on this one, coplanar vectors. What are coplanar vectors? Vectors lying in same plane or parallel to the same plane are called coplanar vector. A vector is said to be a system of vectors are said to be coplanar when they lie in the same plane or their supports are parallel to the same plane, or their supports are parallel to the same plane. So to understand this, I will make a plane here. What is a plane? Everything is a plane. You can see here. This is xy plane. There are three vectors in this plane: BC vector, PQ vector, RS vector. They all are same in same plane. Thus, all these three plane vectors will be called coplanar because they all lie in the same plane. Now there's one more vector called xy vector, which is in not xy plane. Same. Not in xy plane, but its support. Let me draw my support here. Its support is parallel to the plane. You can see if I draw something like this, It's not parallel. There you go. Now its support is like this, and you can see they both are parallel. Thus, xy vector is also coplanar vector because its support is parallel to the plane. But let's take an example of this vector. Tu vector. Is this coplanar? No. It's not lie in this plane, not lies in xy plane, and its support is not parallel to the plane either. So confirm ut vector is not coplanar vector, but xy vector is coplanar vector because its support is parallel to the xy plane. Simple as that. It can be quite complex when you look things from the surface, but when you just dig a little bit, you can understand where these concepts come from. These concepts are coming from the previous topic, the previous video representation of vector, where we learned three characteristics: length, support, and sense. In this one, we use support. In this one, we also use support again. In co-initial, there is no nothing. And in like and unlike vector, we use sense again, and length we're using in everyone. In length will be used too in coming vectors like equal vectors. In equal vectors, length will be used too there. So yeah, characteristics of vector is important too. There are three characteristics, as you know: length, support, and sense. So we had reached coplanar vectors. Now let's move ahead to the next vector, which is called coterminous vector. Let's move ahead. So our next vector is called coterminous vector. Coterminous vectors. We had already learned about co-initial vectors, vectors having same initial point. As total copy paste, coterminous vectors are vectors having same terminal point. Simple. And it's n. Vectors having same terminal point. Or suppose this is a vector and this is a vector 2. Nm vector and Om vector are coterminous because their terminal point M is same. And our next vector is negative of a vector. As I say, when I say types of vector, in most of the cases we are simply saying varieties of pairs of vector. We are not learning some very different kind of vector which reacts different than others. We are just taking scenarios, we are just taking conditions and framing them in the types of vector. Our next is negative of the vector. What is negative of the vector? Negative means total opposite. A vector is said to be negative if its magnitude is same to the given vector but the direction is total opposite of the given vector. It will be very hectic to write. We will say the vector which has the same magnitude a vector which has the same magnitude as the given vector. There will be a given vector, remember, but opposite directions, total opposite direction 180. So what do we mean by that? Let's say there's a given vector called AV. AV is a given vector. Now if we follow the definition, negative of the vector which have the same magnitude, it means if I draw one more vector, it must have same magnitude, and to represent same magnitude we draw the arrow of same length but total opposite direction. Not going here, we will go here, and we will say this. And then vector is the negative of AV vector. As simple as that. Why? Because they both are same in magnitude, but AV vector's direction is opposite of MN's. Opposite is means 180-degree opposite. This is what you call negative of a vector. The next is reciprocal of a vector. Reciprocal of a vector. Using the ideology of negative vector, vector which has same sense of direction but its magnitude is reciprocal of the given vector magnitude. Simple. A vector having same direction as of given vector but its magnitude is reciprocal of the given vector's magnitude. So if I want to represent this too, then let's say this is AV vector, whose magnitude is 2. Okay. So what is the reciprocal of 2? 0.5. This is CD vector. Reciprocal of vector does this. Its magnitude becomes the reciprocal. Reciprocal means 1 by whatever magnitude is there. So this is what you call reciprocal vector. This is simple maths, and as you can say, with simple maths they had make one more type of vector called reciprocal vector. So here, quick recap: coterminous vector, vector having same terminal point; negative vector, vector having same magnitude as of given vector but total opposite direction; and reciprocal vector, vector having same direction of given vector but its magnitude is reciprocal of the given vector's magnitude. So let's move to the final 3 vectors, which are very easy. Our 10th vector is called as localized vector. I'll write definition and then explain. Localized vector. A vector which is drawn parallel to a given vector. A vector which is drawn parallel to a specific point, to a specified point, is called localized vector. It's nothing different. For example, let's say this is a vector, this is a point. Now I have to draw a vector which must be parallel to the GH vector but also passes to P. So there can only be one vector. Not on one vector means there can only be one support. Thus it is localized. AB vector is localized. It is a VIP vector which we are giving special treatment to please pass to the point P. And so to honor them we just say localized. The localized vector is drawn parallel to a given vector to a specific point. Okay? So it's nothing else, just a vector having a name, having a very VIP treatment. As simple as that. As opposite of localized vector are there free vectors. There are careless vectors which have no responsibility to the question. They are just existing there, independent of its position in the space. If the value of a vector depends, if the value of vector depends on its length and direction, on its length and direction, and is independent of its position, and is independent of its position in the space, it is called free vector. In the space, it is called free vector. Means vector just having their own length and direction but independent of its position in space. It is independent any type of situations, any type of scenarios, and is not mandated to follow what other vector do. It's just on its own. A row vector, yes, it would be most appropriate to say a row vector, a vector which has nothing to do with other vectors, just doing its own business. And last but not least, the equality of vectors. Equality of vectors. Equality of vectors. As I mentioned earlier, two vectors, when will be the two vectors said equal? Two vectors are said to be equal only if there are three scenarios. their magnitude must be equal. Their magnitude must be equal. Second, they must have same or parallel support. Third, they must have same sense of direction. Same sense of direction. Very easy. Two vectors are said to be equal when their magnitude is equal, when their support are same or parallel, and their direction are also same. Then only can two vectors can be equal. So here our types of vector ended. We learned about dual vector starting with zero vector whose magnitude is 0, unit vector whose magnitude is 1. Like and unlike vectors, they depend on same sense of direction or parallel sense of direction, whatever you want to say. Then comes our co-initial vector which have same initial point, coplanar vector which has vector lying in same plane or their support parallel to the plane. Then we had coterminous vector having same terminal point. Then we have collinear vectors having same or parallel supports. Then we have negative of a vector having same magnitude but opposite direction. Reciprocal of a vector having same direction but its magnitude is reciprocal of the given vector magnitude. Localized vector which is drawn parallel to a vector through a specified point in space is called localized. Free vector which are independent of its position in space. And then equality of vectors where there are three conditions to say two vectors equal: when their magnitude is equal, when they have same or parallel support, or when they have same sense of direction. Thus our types of vector ends here. This is very small question and we will do that in this video, so that in next when we will come we will move to the fresh topic from the start. So our question is very easy. Those who have listened very carefully can answer very easily. So this is our question, in which the question is, we have given a figure and we have to tell which of the vectors are collinear, which of the vectors are equal, which of the vectors are co-initial, and which of the vectors are collinear but not equal. So let's begin. So which of the vectors are collinear? What are collinear vectors? Collinear vectors are vectors having same or parallel support. Yep. Yes. Collinear vector having same or parallel supports. So we have to find vectors which having same or parallel supports. So A and C, yep. A, C, and even D. D is having same support. It's not in same direction, but it is having same support. So A, C, D are collinear. Then comes equal vector. There are two vectors which are equal, A and C, because their magnitude is equal. They have same support and they have same sense of direction. Okay. Then come co-initial. B, C, D are being co-initial because they have all same initial point. And then last but not least, collinear but not equal. Collinear but not equal. So we have A, C, D which are collinear but not equal. So which of them are not equal? So A and D are not equal because A and C are collinear but equal. Thus D is the only vector in collinear group which is not equals to A. A and D. does it ends here. Very simple question, but can be tricky if you don't use your mind at the perfect points. So yeah, here we will end our video. So please, thank you for watching. Have a nice day. Please like and subscribe if you think that it was worth it. So have a nice day. Goodbye.